Hello everyone, here's another Physics 30 example. This one's the last lesson from Unit 5 on atomic theory. This one's quantum mechanics. So we're looking at de Broglie's waves here, de Broglie, however you want to pronounce it. He basically made the assumption that electrons can behave like a wave. And so he took the photon, let's get a pen here. He took the photon formula, for the momentum, the h over p. So if you know the wavelength of the photon, you can get the momentum. And he just added an mv in here. And this, of course, would be the mass of the electron, or the particle. Actually, it doesn't have to be an electron. It could be anything. Any particle has wavelength. And he said that, yeah, if photons can behave like waves and particles, then so can particles behave like waves and particles. And so what we have here is a question where we're given the speed and the kinetic energy. And so what we should be thinking about with this question, looking at this formula, is, well, there's the speed, but we don't have the mass. Do not fear. Of course, you're given the kinetic energy, which is as good as saying you know the mass, because we also know the speed. So we can say that the kinetic energy is 1/2 mv squared. And so if we want to know the mass, we're just going to go 2 times the kinetic energy divided by the speed squared. So now we can look at our formula. Let's come back over here. Let's pick out let's go, wavelength is now h over mv. Well, we can put this in. We can go lambda is h over, rather than m, I'm just going to substitute this guy into here. And so I'm going to go 2ek over v squared, and then v right here. Now this v is going to cancel with the square, and then I'm going to bring this v all the way up. So that leaves me with the wavelength of this particle is going to be h over 2ek, but I've also got to put my v. So hv over 2ek. Now, the other thing to be really careful of is the type of energy. So I've got 25 kilo electron volts. Now, because I'm dealing with kinetic energy and speed is in meters per second, and so I need a more fundamental or only slightly derived version of my units, which means if I'm using kinetic energy and I'm using speed, I must have this in joules. So I got to convert that as well. I'm going to do that just down here. Let's go 25 kilo, so that's times 10 to the 3 electron volts. I'm going to use my unit cancellation. I want to get my EVs on the bottom, my joules on the top, because then my EV cancels. Well, 1 electron volt is 1.6 times 10 to the negative 19 joules. And so I can now plug this all into my formula. And let's see, the wavelength you should get is, and so here we have all the numbers in. There's my Planck's constant in joule seconds. Here's my speed, and now 2 times the kinetic energy, but I've converted it to joules. So if you plug that into your calculator, you're going to get, what are you going to get? You're going to get 5.39 times 10 to the negative 12 meters. So that's an X-ray. And check this out. Look at all these units to cancel out. This is beautiful. My EVs cancel, my joules cancels, and my seconds cancels. Ta-da! Leaves me with my meters, which is what I want. Perfect.